Hello all, welcome back. In this session, we are going to discuss about bias and variance in machine learning algorithm. And bias and variance. The two important sources of errors in machine learning are it helps to explain the underfitting and overfitting issues and importance for model performance. And the total error is calculated by means of bias square plus variance plus noise. Where what is meant by bias? It is error due to wrong assumption. In simple words, we can say it is the difference between predicted value and the actual value. That variance, it is due to the sensitivity to training model. How the training model varies with respect to when you change the training data. How more it is sensitive, right? Fine. What is in by bias? In bias, it is the difference between predicted value and the true value. It occurs when the model is very simple and it cannot capture the real pattern of the dataset. And right hand side, this image source for underfitted, and this is a robust model. For the dataset is curve like structure, but the straight line to fit a curved dataset is an example of bias. So it results in underfitting. And what is in by variance? Variance measure how much the model changes with respect to training data changes. Fine. So this model will try to memorize the training data. So and it will lead to overfitting. The model is too sensitive to training data. Small change in data will lead to large change in the model. So that's the best example is it will start to memorize the data. So it results in overfitting. And we can see this case with the help of target board example. And simply we call it as bias variance trade-off. We have four quadrant 1, quadrant 2, quadrant 3 and quadrant 4. And this is low bias and low variance condition. This is the actual model we want. This in target board example, the center board is our actual value, right? And the predicted values are given in dotted marks. So this is the condition we want, low bias and low variance condition. But whatever decision tool will do, it will fit on this low bias and high variance condition. Prediction vary wildly. See here, this target board is our actual value. The predicted dotted points are scattered around the actual value. The error is something there. So it will lead to high variance condition. And the third quadrant may call it as it is high bias and low variance condition. The predictions are far from the true value, but see here it is very consistent. It is true from the actual value. It is far away from the actual value, and all those values are the particular consistent, but it leads to high bias and low variance condition. You are getting this value. And the fourth quadrant is a very worst model. It is very scattered. Its condition is called high bias and high variance condition. And in this example, see here, bias variance trade-off in 2D way. You can able to have this picture. You can use this picture for your exams too. In the consider in x-axis you have model complexity. When you move from 0 to right hand side, the model complexity gets increases. Same way you can consider error in y-axis. The y-axis increase from 0 to maximum value. So our model should be a unique ideal model with low error. Same way it should have less bias and less variance. Less variance by mean error should be very less, and bias also should be very less. See here, this dotted mark indicates the ideal model. At this particular point the error will be less, the model complexity will be moderate, and error will be also less. This was the model we are going to choose. But the left hand side of the dotted mark comes under underfitting, and the values that comes under right hand side of this dotted mark says it is a overfitting criteria. So decision tree will falls under this criteria, where by model increases, the bias, the error will be somewhat get increased, right? And it will start to memorize the data. The variance is very high. This is the drawback of decision tree algorithm. In another video. Thank you.